So today our chapter is chapter 6.1. It's the law of sines, and we're gonna see where do we use the law of sines, in which kind of triangle. First, let's review. If we have a right triangle, we find the sides and the angles using Pythagoras theorem or using the trigonometric functions. So these are the 6 trigonometric functions: sine A equal opposite over hypotenuse, cosine A adjacent over hypotenuse, tangent A opposite over adjacent, cosecant is 1 over sine, secant is 1 over cosine, and cotangent is 1 over tangent. So these are the 6 trigonometric functions we learned so far, and we use them if we have a right triangle. It means a triangle that has an angle of 90. So we learned from the previous slide how to find the sides if we have a right triangle. But what if we have an oblique triangle? What is an oblique triangle? It's a triangle that does not contain a right angle. In other words, it has either 3 acute angles or 2 acute angles and 1 obtuse angle. Now this is the law of sines. So we find the law of we use the law of sines with oblique triangles to find the sides and the angles. And let's take a look over here. So if I have angle A, this small side facing it, we call it small a. If I have angle B, this small b here is the side facing it. And if I have angle C, this small c here is the side facing it. So the law of sine say A over sine A, which is capital A is the angle, equal to B over sine B equal to C over sine C. And also we can write it differently as sine A over A equal to sine B over B equal to sine C over C. So we can also flip the reciprocal. So let's see the first example. So we have a triangle where A equals 64, C equal 82, and we have C equal 14. And we need to find the other sides. So we need to find what is A, we need to find what is B, and we need to find this angle B here. So first we can find angle B by using that the sum of angles in any triangle is equal to 180. So we don't need to use the sine here law to find angle B. We can use this fact that the sum of angles in any triangle is equal to 180. I have 2 angles, which is A, and I have C. I can solve for B. So by solving for B, B is 34. Now we need to find what is angle A, what is side A and what is side B. If I look at my triangle, let's see what do we have. We have the 3 angles, but we have one side here we can make use by using the law of sines. So we're gonna use, we don't have to use the 3 of them at once. We can take 2 proportion. So we took A and angle A, and we took C and side C. We cross multiply. So this is A sine C equal to C sine A. From this, we solve for A. And A turned to be 12.7. Now we have A. we need to find B. So we're going to use another sine rule. B over sine B equal to small c over sine C. Cross multiply and solve for B. B turned to be 7.9. So again, these are two proportions. We can cross multiply and divide. We solve for B. B is 7.9. Another example, we have a triangle where A equal 40 degrees, C equal 22.5, and we have small b equal 12. We need to find the missing angle, which is B, and we need to find the missing sides. So for B, we can find it using the fact that sum of angles in any triangle equal to 180. So this has nothing to do with the sine law. We plugged in the angles we have and solve for B. And we got B equal to 117.5. Now we still have to find A, and we still have to find C. So here we're gonna make use of the law of sine. So we took B with the side facing it, and we're gonna take A definitely with the side facing it, because that's what we need to find. We need to find small a. So cross multiply and divide. We got A equal as 8.7. Now we still have to find small c. We're going to use another sine law. And here we have so many options to take. So again, cross multiply and divide, and c equal 5.2. So the area of an oblique triangle. So we have the area is half b times c times sine a, and here a is the angle between b and c. Here c is the angle between a and b, and here b is the angle between AC. So the formula is half b times c times sine a equal half a times b times sine c equal to half a times c times sine b. So this is the formula for the area. So after we've seen the formula, let's see an application of the formula. So after we've seen the formula, let's see an application on the formula. So this is an example where we need to find the area of a triangle having sides of length 8 and 12, and we have the included angle as 135. We need to round the area to the nearest square meter. So let's look at our triangle. What do we have? We have A, and we have B, or in other words, small b, and we have small a as 12, and we have the included angle as 135. So out of the three formulas expression we have, we're going to use the one that has small b, small a, and we're going to use sine c. Plug in everything, and be careful when you calculate sine c on the calculator. Your calculator should be on mod degree, We need to round to the nearest square meter. It means to the nearest whole number. So no decimal. So to the nearest square meter, it means to the nearest whole number. There should not be any decimal. And the answer is 34 and square meter. Square meter here, because it's a unit of area, we can write it as such also. Always the unit of area should have 2 on top, because that's we mean by square meter. So this is the last example. We have 2 fire lockout stations. They are 13 miles apart, with station B directly east of A. Now, both stations, they spot a fire, and the bearing of the fire from station A is north 35 east, and the bearing of the fire from station B is north 49 west. How far to the nearest of a mile? The fire from station B. So this is what we need to find. So definitely we can use the law of sine to find this sine. Now, first we can find A. What is A? By subtracting it from 90, because we know this angle here is 90 degree, and also we know this angle here is 90 degree. So we can find also what is B by subtracting it from 90, and we can find what is C by using the fact that sum of angles in any triangle is equal to 180. Now, after we found the angles, what is A, what is B, and we know what is C, so we're going to use the law of sine, as you can see here. And he said, find the side to the nearest tenth of a mile. Nearest tenth of a mile is the first digit after the decimal point. Since there's 0 next to it, we're going to keep that digit the same. So the answer is going to be, the fire is approximately 10.7 miles from station B.